Problem 10. In the rectangular parallelepiped as shown below, AB is 3, BC is 1, CG is 2. Point M is the midpoint of FG. What is the volume of the rectangular pyramid with the base BC, HE, and apex M? Notice that this shape, I'll do it, so like this shape right here, right? You see that shape? This 3D shape is the area, the volume that we want to find. But that's a very bad looking shape, right? It's not a special figure of any kind. There's no volume formula I can apply to it. So let's actually do complementary counting, which is let's find the total volume of the cube and then subtract out the volumes that we don't want. Starting with this shape, we're going to start with this 3D looking shape right here, right? And you can imagine, right? This is the bottom volume, and that volume we don't want it because that's not part of the volume that we do want, BCHEM. So what is the volume of this shape? Well, this shape, the volume of this is equal to, well, this is a what? That is half of the total volume of this cube, right? You can imagine it. I just put a slant right here, and that divides the volume in half. So what is that? What is the volume, in other words, of this cube? Well, the volume of the cube, I'll do this in orange. The volume of this cube is the total volume that we don't want, which is the same thing as the length times the width times the height, which are all given, which is 6. So that's equal to 3. Now let's consider the other areas we don't want. We don't want this tetrahedral right here, if you can see it in green. This tetrahedral looking shape, which if I trace it out will look like this roughly, this shape is really something we don't want because that's not within the region, right? So the volume of this is equal to what? Well, the volume formula for a tetrahedral is 1/3 base times height. Base is the base area. So what is the base area for this is E, that's F, right? That is M, and that's B. Well, we can find the base area as this right triangle right here, right? So that right triangle, which is just the same thing as 3 times 2 divided by 2, which is equal to 3. So base is equal to 3. Now, what is the height? The height is equal to FM, and FM is this side length right here in blue. In this side length right here in blue. So that height is equal to 1/2 times 1, which is equal to half. So that means our volume for this will be 1/3 times the base of 3 times 1/2, which is 1/2. But notice here, we have another tetrahedral that we don't want. If I do it in this violet color, which is right here. Do you see it? That 3D shape is another shape that we don't want because that's not within the overall volume. And that volume is the same thing as this, because just by intuition, right, just looking at it, this tetrahedral is the exact same thing except we rotate it a bit. And other than that, it's the exact same shape. So this volume is also the same thing as 1/2. Now with this, remember, you have to have a healthy amount of intuition, right? You can't just keep solving it. And if you were to solve it again, right, you realize that, oh, they share the same base area, they share the same height, therefore they would have the same volume. But nonetheless, what is our volume of this shape right here, right? This looking shape. Well, that volume would be equal to 6 minus 3 minus 1/2 times 2, which is the same thing as 3 minus 1, which is 2. So your final answer would be answer choice E.